Hello everyone, welcome to Decode ITES. This is a single learning platform for multiple IT infrastructure technologies. Do like, share and subscribe our channel to never miss out our videos. Let's continue with the learning. Let's have a small introduction of myself. My name is Prince Garg. I'm having 3+ years of work experience and worked on Red Hat, VMware, Windows, Google Cloud, PowerShell, Python and Bash scripting. Kindly follow us on Facebook, Insta, LinkedIn, and reach out to us on itesfund.com. Welcome back everyone to Decode ITS with the learning of Linux 8. In this lesson, we will cover up the file ownership and permissions in Linux. I will cover up with the basics of it by which you can work under the environment. So the first thing is file ownership and permissions. Linux is a clone of Unix, the multi-user operating system, which can be accessed by many users simultaneously. Linux can also be used in mainframes and servers without any modifications. But this raises security concern as an unsolicited or malignant user can corrupt, change, or remove crucial data. For effective security, Linux divides authorization into two levels: ownership and permissions. Let's take a look on them. So the first thing is file ownership. Every file and directory on your Linux system is assigned three types of owner given below: user, group, and others. A user is the owner of the file. By default, the person who creates the file becomes its owner. Hence, a user is also sometimes called as an owner. A user group can contain multiple users. All users belonging to a group will have the same access permission to the file. Suppose we have a project where a number of people requires access to a file. Instead of manually assigning permissions to each user, we could add all users to a group and assign group permission to file that only this group members and no one else can read or modify these files. Like in the previous videos, we have checked how to create a group in Linux and how to assign membership of that group to the users. So if we did that, like we have created a group by name test group and we are having 10 users under it, like the membership of it, then we can assign the ownership permission to that group and the users will automatically get that permission. The last one is others. Any other user who has access to a file, this person has neither created the file nor he belongs to a user group who could own the file. Practically, it means everybody else. Like if we are having multiple users under the environment, obviously, then a user by name of Prince is not the user who created the file, like Ankit created the file. And also, Prince is not having the part of test group. So by this permission, he can get the access which we set up for that file. It means hence, when you set the permission for others, it is also referred as set permissions for the world. Now the big question arises, how does Linux distinguish between these three user types so that user A cannot affect a file which contains some other user's B's vital information, or we can say data. It is like you do not want your colleague who works on your Linux computer to view your images. This is where permissions set in and are helpful, and they define users' behavior to work on that particular file or folder. Now it comes with the file permission. Every file and directory in our Linux system has following three permissions, defined for all three owners as we discussed above. Read, write and execute. The read permission gives us the authority to open and read a file. Read permission on a directory gives us the ability to list its content only. Write. The write permission gives you the authority to modify the contents of a file. The write permission on a directory gives you the authority to add, remove, and rename files stored in the directory. Consider a scenario where we have to write a permission on a file but do not have write permission on the directory where the file is stored. We will be able to modify the file contents but will not be able to rename, move, or remove the file from the directory. Execute. In Windows, an executable program usually has an extension like .exe, .msi, many extensions, and which we can easily run. In Linux, we cannot run a program unless the execute permission is set up. If the execution permission is not there, we might still be able to see or modify the program, the code, provided read and write permissions are set, but not run it. We can see the file, but we can't able to execute it until we are having the execute permission on that file. So owners assign permissions on every file or directory. We are having user, group, and all other users. All three are having read, write, and execute type of permissions. And that permissions is related to a file. Like every file is having read, write, and execute permission for user, group, and others. Understanding the security permissions. First, we must think of those 9 characters as 3 sets of these characters. Each of 3 RWX characters refers to the different operation we can perform on the file. If you look at the diagram, if we check permissions of any file under the Linux environment, we will get the output like RWX, RWX, RWX. These are 333 digit set. The first one is for user, second one is for group, and third one is for others. So the permissions are in the form of read, write, execute, and dash. R means you can read the file of the content. W means we can write or modify the file's content. X means we can execute the file. This permission is given only if the file is a program, like the sh or pl scripts. If any of the RWX character is replaced by a dash, then that permission has been revoked. Like if you see RW dash, then it's not having that execute permission. User, groups, and others. The user permission apply only the owner of the file of the directory. They will not impact the actions of other users. The group permissions apply only to the group that has been assigned to the file directory. They will not affect the actions of other users. The others permission apply to all others users on the system. This is the permission group that you want to watch the most because anyone can access the file or take out the data from it. So that's all with the permissions set, and we will discuss more in the next lesson with the practical overview session. If you're having any queries related to this topic or any another topic, you can just reach out to us on decodeitsfun.com, or you can drop a comment in the comment section below. Thank you. Thanks for watching. Do like, share, and comment our videos. Also subscribe to our channel.